Nice for hanging. Yeah, now my topic is back to some practical problems. I would like to introduce you the method for the serial three-dimensional documentation of ceramics. And I had the possibility in spring 2018 to went to the excavation site in el-Burak in Lebanon. And my reason to be there was the idea of the archaeologist Dr. Aaron Schmidt from the Johann Gutenberg University in Mainz to try a three-dimensional documentation of his Iron Age amphorae sherds and to evaluate the comparability with the conventional drawing method on excavations. So in this pilot project, well-trained craftsmen documented a significant selection of 100 sherds with the classical drawing method. So drawing the sherd and the profile, measure significant values, make pictures from both sides, and digitize the drawings. In this, it's important to mention that in this stage that there was, or all the sherds were undecorated pottery. So they are the fastest to document. We will see later what it mentioned. Here on the top, you see the results of the drawing and the associated pictures. And my job was now to find a method which can bring at least the same information or even more. And so, okay, how to start this first? I read a lot of literature because I thought somebody must have done that before, but I don't find anything. So I only find the digitization of one sherd or scanning with a white light scanning system. But so my thoughts on this were that because of the low budget in third-party project, a scanner was out of the question. And so we decided from the beginning to take the structure from motion photogrammetry method. And now, how to arrange the sherds for good recordings. A frame, like some others use, covers too much surface for us, so we need another solution. And another question was how many sherds we can record at one time. So sure, we want as many as possible, but it always depends on the focal length and the size of the sherds. The next problem was that many sherds make a lot of shadow, so we need a diffuse light scenario, which is largely independent from the environment. And finally, excavations have always a tight timetable, though the method has to be time-saving and therefore serial and if possible, semi-automatic. And at the end, we need an accuracy of 1 millimeter to use the data for scientific measurements. To make it a little bit even more complicated, there are further regulations on international campaigns. Like you never have enough money, but always far too many ceramics. You have limited time and often no technical stuff for surveying and things like that. And with all the stringent conditions, the following method is a result of a 2 weeks experimentation phase on site. So here you can see a so-called ceramic tree. Yeah, with the opportunity to fix 8 to 16 sherds. It depends most on the size of the sherd. So if you have small sherds, you can pick up to 16. We put it on a rotation table with markers for the dimensional accuracy. Put it in a light tent with white background, so you have the diffuse lighting scenario. And yeah, I tried this setup in the shadow of a tree and it worked perfect, but you can also use a tent or maybe also an umbrella will work, I think. The acquisition is done with a high-resolution digital SLR camera on a tripod. And we took between 18 and 90 pictures per stage. And every sherd is turned over to record the leg of the clamp where we put the sherd. For the processing of the sherds, we do several steps in Agisoft and MeshLab. Beginning with the cleaning of the point cloud, separate the sherds into stages, then align and merge them. and finally texture the resulting surface model. And this is how it looks like. On the left, you can see the model with the complete texture, in the middle without, and on the right side, the picture of the original shirt. And what we actually want to achieve with this result is a working sheet, which is suitable for scientific research, and that you can compare it to the output of the classical drawings. Okay, the animation doesn't. Oh, okay. For that we make a 6-side view, a reconstruction with the help of a body of rotation, and we put in the relevant measurements, and also want to put in a link to the online repository so that you have all together and can have a quick look at the original 3D model. And here, okay. Here you can now see a summary of the required time of the individual work steps. In the beginning, it's important to say that I ignored the calculation time of the software. Since this can also be done independently out of working hours, and these are the extrapolations from the documentation of 96 shirts, and at all you see there's just a small advantage when you record 16 shirts, because the recording time is just a fraction of the whole processing time. Yeah, and here you see the comparison of the drawings, doing the drawings and the digitizations. And I would like also to emphasize again that the classical drawing was made only on undecorated pottery, and the time required for decorated shards increases enormously when you are drawing them. So and in summary, we can say that the digitization keeps up in time and quality with the classical drawings, especially if you have decorated pottery, and the additional texture calculations increases the processing time, but has the big additional value that you have a complete 3D model for reuse. And finally, all this should lead to an easy-to-handle manual for everyone on excavations. And in the future, it should be used in training for the antiquities departments. We want to try it first in Lebanon, but maybe then other countries will follow. Yeah, thank you.